common sense in the Riemann hypothesis. We will discuss the Riemann hypothesis and give a common sense explanation for it. Here is Riemann. He lived about 150 years ago. He came up with a function known as a zeta function, the Riemann zeta function. 100 years before him, Euler came up with 6 functions known as the Euler zeta function. So here is a simple common sense explanation of the Riemann hypothesis for Kanga. We go back a couple of centuries in time, 3 centuries, the age of Euler, the mighty mathematician. At that time, the great and beautiful Queen of France has decided to distribute royal cakes to citizens of the world. Every citizen of the world will be contented with his or her lot and lead a happy, blissful life. However, the miserly King of France will allow only one small coin of money to be spent for the entire world. So Euler is respectfully invited from the court of the Tsar of Russia when he was working, from the court of France to solve the problem of staying within the budget. Euler says one small coin of money is ample money to distribute the cakes, and suggests distribution as per the harmonic series, or better still as zeta. This means a lesser and lesser amount of volumes of cake to citizens as distribution proceeds. Riemann, deputed later on by the emperor of the land of the gods, goes a step further. He suggests distribution as per his zeta function. If we follow Riemann's zeta function, we will grow smaller and smaller imaginary portion of cake as distribution proceeds. Piclet is appointed Director General of the Cake Distribution Project for the Court of France. Piclet decided to distribute cakes to the rest of colony of New York, his hometown, whose citizens were becoming warlike. So he gets royal permission from the King of England to do so. He selects the most important citizens of New York, poor and eager, and distributors general cakes in the power direction. Distribute cakes to one end of New York to the other. He selects the second important citizens, super poor and super eager, and distributors general cakes in reverse direction. Distribute the cakes in the reverse direction. Both the parties distribute the cakes to reach the center of New York. An equal amount of cake is given to both poor and eager and super poor and super eager. This is what gives symmetry in the famous RE half Riemann chapter. When the cakes are being distributed, the peers, troubles, and Redinians who do not like the fact that squatters have come, settled in the backyard, they start eating and walking off with bottles of cakes. When poor and eager arrive in the center of New York, we find eager is half a house ahead of poor. In the other direction, when super poor and super eager arrive in the center of New York, we find the super poor is half a house ahead of super poor. The net effect is eager is one house ahead of poor, or alternatively, super eager is one house ahead of super poor in the center of New York. Also, we have the fact that the population of New York is a composite number, which has a factor in the center of New York. And this means a lead of one house of eager over poor, or super eager over super poor. The Redinians for the untiring leads, and this corresponds to residues, walk off with half of the house in the direction, and we're left with zero of the Riemann stuff. If we vary the population of New York with suitable immigration procedures to all possible composite integers, if each pair of integers correspond to the composite integer, one of the factors, we can use zero of the Riemann zeta function. All the zeros occur in the middle of New York, which means on the line RE half perspective. If we take New York as a complex plane, in the middle is RE half. The amount of cake the Indians have walked off with is good by half is Isaac, and a zero of the Riemann zeta function. There is an indicator of how much cake has been distributed by poor eager and how much the same amount is distributed by super poor, super eager. This includes the amounts appropriated by savage Canadians. Now, since there are infinite number of opposite numbers, and New York can go vertically, we have infinite number of zeros with the Riemann theta. If we exclude the concept of Tower of Babel, the growth of New York vertically, then all the zeros of the Riemann theta function occur in the middle of New York on the line RE half. And this is what the Riemann hypothesis is all about. Now, as a footnote, we see complex variables in the zeta function means multi-value functions. But it turns out integer factorization has been shown by Euler to be periodic. So the multi-value nature is taken care of by integer factorization. It's formalized by Piglet in the Piglet transform. So this is the explanation